Alright, welcome to our CNT 140 Lan Wiring class, Chapter 10. This chapter will be discussing open office wiring. Now the objectives that we'll be highlighting are modular offices, the 568C TSB 75 guidelines, consolidation point, multi-user telecommunication outlets, fiber optic cabling, separation from the AC power cables. So, let's begin. Now, open offices themselves present some interesting problems for structured cabling. Open offices include the popular modular furniture rooms, the cubicles, as well as classrooms, training facilities, and shops. These office arrangements are used in many medium to large enterprises that have a need for compact workspace for their office workers. Office cubicles form a familiar type of modular furniture arrangement. The very flexible nature of these open offices means that the fixed wiring that is used in the other office environments is not practical. In addition, the modular furniture, like the one shown behind me, is frequently placed into the rooms at the last step, long after in-place wiring should have been completed. There are a number of other issues that complicate the landscape and create problems for the cabling installer. Now, we'll go over two of the most popular approaches to open office wiring, along with the guidelines for solving these issues, and according to the standards. Now, modular offices, modern problems. In the original concept of the structured cabling embodied in the 568 and the EAA 568 and A, horizontal cabling is run directly between the telecommunications closet and the work area telecommunications outlet. Now the outlet is presumed to be permanently mounted in or on the office wall and is expected to be within a relatively short distance from the actual workstation or device. Now this presents several difficult issues with regard to modern modular offices. These office environments use modular furniture designs and modular walls to form cubicles with built-in work desks. They effectively replace both fixed wall offices and totally open desk pools. The arrangements are popular because they make much more effective use of the office area by eliminating closed-in offices, and they afford a measure of privacy and personalization that is unavailable in the open room with a desk array. Modular furniture systems typically place power and communication cables in narrow pathways within the panels of the modules, like the example shown here. These modules must be fully assembled before the cable can be inserted, which makes the process of providing home-run cables to the telecommunications room more cumbersome. This means that portions of the data and telephone cabling process must be postponed until the modular furniture has been assembled. At this stage in an office build-out, the ceiling tiles are already in, the walls are finished, carpet is laid, and the modular furniture all over the place. Placing ladders to install standard horizontal runs is difficult, even if the cable has been pre-pulled to the expected area of the power communications riser. Now, if pre-pulled, enough wire must be left coiled into the ceiling to run down later through the pole and through the wire pathway to an outlet connector. This leads to wasted wire, and in the best case, an insufficient wire in the worst case. In addition to the wire pulling problems, the installer has the delightful task of crawling down on the floor under the modular desk with flashlight tools to terminate the horizontal cable into an outlet. After all this is done, the installer can finally use a cable scanner to see if the link even passes. Then, any problems that have occurred must be solved at great time and expense. The significant cabling problem that occurs with the use of modular offices is that the modules can be easily rearranged. Furniture modules are very easy to move about. The modules simply unbolt the same way they are originally bolted together, and then they're moved as needed to reconfigure the office to meet new personnel requirements. In most of these modular furniture systems, electrical connections either snap together as the modules are joined, or they're easily cabled out and extended by a system of plugs and receptacles. Unfortunately, the communications wiring, including our LAN wiring, must be painstakingly removed and rerouted into the new furniture layout. And in many instances, the relatively delicate fiber and copper cables are the wrong length in the new arrangement and cannot be reused. The only option is in such a home run environment is to pull an entirely new cable to each relocated workstation. At an earlier time, this was the only approved method to run and rerun standards compliant with Category 5B and higher links, as the standard allowed no splices or intermediate couplings. However, a much better alternative is to run the horizontal receptacles to a series of distribution points within the open area. Typically, these points of termination are along the walls in the same area where electrical power will connect to a set of modular furniture. In some instances, the distribution point might be in a ceiling area with the communications wire distributed to the furniture modules nearby. Then, after the furniture is installed, cables can be extended to the distribution point, to the workstation outlet within the modules. This has now become an almost universal practice in open office installations. This method is not only much more practical, but also a good deal less expensive, labor-wise, with dealing with home runs. Despite the standards to the category, despite the standards to the contrary, these links normally work fine and pass the applicable link test. Early on, however, a few links failed, and it became obvious that some standard practices need to be created to ensure that the needed performance parameters were preserved for the appropriate category of operation. The TIA HACC TSB 75 guidelines, additional horizontal cabling practices for open offices, originally added the rules for handling modular furniture. Now, the Telecommunications Service Bulletin, TSB, provides additional information and practices to supplement an approved standard. In this case, the 568A and TSA 75 put down on paper the information that installers need to provide or properly provide standards compliant cabling in an open office environment. In investigating the open office practices that were in use, it was determined that essentially two variations were popular and successful, providing a location to group or consolidate cables and placing the equivalent of a workstation outlet at the cable, grouping and running longer user cords to each workstation. The consolidation point method initially terminates a horizontal cable at an appropriate punch-down block at an intermediate distribution point between the telecommunications room and a group of open office workstations when it is time to extend the link to the open office module. Another length of horizontal cable is connected to the punch down and run onto the workstation outlet. The multi-user outlet method actually places the workstation outlet at the distribution point in multiples to match the circuit modules and runs an extended length user cord to the work area. Now we'll go into each of these methods in some detail in the sections that follow. The provision of this standards bulletin gives the system designer and installer the ability to provide approved intermediate interconnection points for modular offices. Guidelines for cable length allowances that will meet the performance requirements are given in the standard, and we will summarize these here. Let's talk about the consolidation point. Now, it is a point within the horizontal cable run where two cables are interconnected, as you can see behind me. And in reality, it is a reusable connector, such as the punch-down block, that effectively joins the two cable segments without being officially called a splice. In fact, cable splices are still forbidden, presumably because they do not allow reusability and make poor connections when viewed from the perspective of crosstalk and return loss. The connecting hardware for the consolidation point is required to function at least 200 mating cycles. Now, this requirement is already the case with all the normal connecting hardware under the standard, but is a more significant limit for the connecting blocks used with punch downs. You will need to be sure that the hardware meets this limit. This number of cycles is quite sufficient in allowing for the periodic movement and reattachment of a portion of the horizontal cabling that connects to the work area outlet. All cables and connecting hardware used in a consolidation point should meet all the performance measures of the 568C, including the transmission parameters for the applicable category of operation. In addition, the actual location of the consolidation point should be placed more than 15 meters from the TR because of the short cable problem and the added crosstalk effect. If you need to connect to a consolidation point that is closer to the TR, closer than 15 meters, the recommended method is to coil extra cable until the maximum distance is met. all connecting hardware for the consolidation point must meet or exceed the requirements for the category of operation that you need. In other words, a Cat 5e or 6 or AC6 installation must use a punch down that is rated at Cat 5e, 6 or A6 or higher. Additionally, installation methods must meet the same category of operation. Now, just as with any connection within the link, the placement of the consolidation point within the open office is another important consideration. Clearly, the points of consolidation of all these cables must be easy to access in a permanent location. It'll do little good to provide a handy distribution point for the modular furniture outlets and face the possibility of that location being moved. As you can see from the diagram, this method does redefine the work area to encompass a consolidation point. This allows one to say that the horizontal run to the work area still can remain splice-free. All other cabling distance guidelines remain the same. Horizontal limit is still 90 meters, and the user cord limit is still 5 meters. The consolidation point is simply placed somewhere within the 90-meter run. The main advantage to this cabling method is that it does allow for an intermediate connection point for the last part of the horizontal run to the work area outlet. In the event that the furniture is moved or reconfigured, only the portion of the horizontal run from the workstation outlet to the consolidation point has to be replaced. And most of the cable would have to be rerun within the modular furniture's pathways anyhow. The requirements for making the cables in the consolidation point are the same as in any other cabling location. The details on the marking of these facilities are covered in the 606A and elsewhere in the book. Now keep in mind that you may have an additional opportunity to lose track of cable connections because of the consolidation point. The best practice is to be very orderly in placing the modular furniture ends on the horizontal cables and onto the consolidation hardware. Mark both cable ends as you go and try to keep the numbering consistent. For example, rather than label an entire run with the number C310, you could differentiate between the two legs on either end of the consolidation point by making one A and one B. So let's look at multi-user telecommunications outlet assemblies. The consolidation point architecture is one of the most common methods of providing for open office cabling. However, it is not the only alternative. Another logical method is to simply extend the length of the user cord far beyond the normal 5 meters limit. It turns out that the lengthening of the user cord can be successfully accomplished on shorter horizontal cable runs. Now this accounts for the early success of some open office wire methods prior to the existence of these standard practices. The most logical arrangement for an open office with extended user cords is to bring all the cords together at a wall or other permanent structure upon which the appropriate number of workstation outlets can be mounted. This description essentially defines a multi-user outlet arrangement that the HACC calls a multi-user telecommunications outlet assembly. Fortunately, the industry has nicknamed this the MUTOA, or just a multi-user outlet. The multi-user outlet method is shown here behind me, and the basic premise of the multi-user outlet method is that the operating parameters of the channel must be maintained for proper operation of equipment that is connected according to the 568C. So as long as the installed link criteria are met, there can be allowable versions in the absolute lengths of the horizontal cabling and user cords. It is well established and it is included in the component standard that the stranded conductor cable used for user and patch cords has a lower velocity of propagation and higher losses than the solid conductor cable that horizontal runs. The TSB utilizes that effect in determining how much to decrease the horizontal cable allowance as the user cord is lengthened. This derating factor turns out to be a very good approximation of how much link performance is degraded by unusually lengthy user cords. These long user cords can be threaded through the modular furniture raceways in much the same way that the unterminated horizontal cable was in the consolidation method. The cable raceways in modular furniture normally have removable panels along their length, so the only difficulty is to run the connectorized cable ends through the openings in these structural columns placed for this purpose. Care should be exercised in this process, as there is ample opportunity to bend, kink, or cut the cable during the installation into modular furniture. Some of these removable panels are constructed of metal, so the installer must also be cautious of sharp edges. Also, the electrical power to the module should be turned off for safety reasons during the installation of the cable into the module. Note that there is no workstation outlet in the normal area of the workstation. The work area outlet is in fact part of the multi-user outlet assembly that serves all the nearby modules. The extended user cord is run through the modular furniture and plugged directly into the user workstation. Excess user cord length. The other issue that must be dealt with is the excess cable that will be left over. Now, unlike horizontal cable, which must be trimmed to within 18 inches of excess cable at the workstation outlet, the user cords are normally fixed length, manufactured cords. Cat 5e, 6 or A6 field termination of stranded cable into modular plugs may be outside the ability of the average cable technician because of the narrow tolerance in the placement of the conductors from the plug. Now, if you must trim to length, follow the methods that we discussed in Chapter 9 for terminating the cable. If you use manufactured cables, the excess must be either stored in the work area or in the multi-user telecommunications access panel. One possible storage method is to use one of the cable management devices to store the excess cord length. These can be slide raceway or a series of cable management rings or standoffs, or one of these snap-in-place cable management devices. In general, any device that can be used in the TR to manage patch cables can be used here. Horizontal distances for the MUTOA method needs to be discussed. The formula for this calculation is given in the standard, but the maximum horizontal runs for several lengths of cable work area are shown here in the table. Now, as you can see, the length of work area cord is the normal 5-meter length at the maximum horizontal distance of 90 meters. Now, this is a total of 95 meters, and when added to the cross-connect equipment cable length of 5 meters, it yields the total of 100 meters, on which most of your land topologies are based. However, at the maximum user cord length of 20 meters, only 70 meters of horizontal cable would then be allowed, rather than the expected 75. The reason being is that the 20% greater attenuation loss for the stranded user cable. Now, the total length allowed for the channel in open office wiring is always at or below the length in normal horizontal lengths. In testing a link that uses the consolidation point method, the normal tests for basic link and channel are still completely valid. However, if you use the multi-user outlet method, the differences in the allowable horizontal run and the user cord lengths are significant. You should do a preliminary check of the run of the MUTOA in accordance with the basic link test parameters, but you should allow an extended pass margin to compensate for the slightly poor performance of the extended user cord. In the end, you really must check the entire channel link, as that is the ultimate connection path on which the high-speed network must operate. If equipment and patch cords are not yet installed in the TC, you might consider testing the channel using the actual extended user cord and the 5-meter maximum equipment patch cord. Now let's look at fiber optic cabling in open offices. Now, no discussion of the shortcomings of twisted pair cabling will be complete without mentioning fiber optic cabling, but most of the problems with copper cabling occur at the point of termination in interconnection. This is a place where the impedance mismatches, the untwist, near-end crosstalk, far-end crosstalk will occur. The only similar problem for fiber is the introduction of a very small additional attenuation and mismatch that occurs at termination. In a typical fiber optic link, there's plenty of margin for a small transition of attenuation. For that reason, the only structured cabling limitation placed on fiber for open office is that the total length of cables and patch cords may not exceed 100 meters. Now, that is otherwise stated in the standard. Now, with a typical connector, loss of about 0.2 dB, you can add a lot of terminations, patches, and splices with little or no effect at only 100 meters. In addition, you can use the TSB 72 guidelines for length if you are connecting open office workstations using a centralized fiber network scheme. Consult Chapter 11 for more information on fiber cabling. Now, using a fiber optic MUTOA cabling for open office is always considered to be the multi-user outlet method. Fiber cabling does not use the punch-down method for copper wire and thus cannot use the consolidation point method. However, there are several important considerations for using fiber with open offices. Fiber optic cabling must be carefully managed to prevent any possible damage to the fiber during and after installation. At the MUTOA, the fiber cable will have to be separated out to individual fibers and each terminated in a fiber connector. At this stage, the fibers are tiny, relatively unprotected, jacketed strands that are highly susceptible to damage. An enclosure such as a fiber termination tray is the best way to deal with this problem. The best fiber termination enclosures are the same ones that are used in the TR. Smaller versions are available for use with the multi-user distribution points. In very limited modular furniture terminations, it may be possible to use some of the innovative multiple connector outlet boxes that are designed to terminate from 4 to 8 fiber pairs. Now, these outlet boxes are designed to contain the extra lengths of unjacketed fiber strands that are required at the point of termination. They are often available in surface-mount versions that are easy to place above the ceiling grid on the walls surrounding the open office space. The availability of small form factor connectors for fiber makes this method even more practical. Small form factor connectors place 2 fiber strands in an RJ-sized modular jack that snaps into the outlet box the same way as the jacks were designed for copper. Now, because fiber is terminated and interconnected in a fundamentally different manner from copper, all open office wiring systems for fiber are considered to be the MUTOA method. This is true whether you are using the standard horizontal run from a telecommunications closet or the optional centralized cabling method covered later on in Chapter 12. Fiber cable strands are generally terminated in a male connector, which is interconnected by aligning the fibers in an adapter receptacle. There are terminations and connections at the hub switch in the TR, at the patch panel, at the MUTOA, and at the work area outlets are identical. The insertion and return loss that result from each termination are comparable to a normal termination. And the only parameters that must be watched are the total path loss and the optical bandwidth. As a result, the point of interconnection the fiber runs can be just as easily placed in the open office area as in the telecommunications closet. So let's look at a little separation anxiety here. One of the side issues that arise in open office cabling is the separation of communications cables with power cables. The reason for this is that there is some concern regarding the potential interference from power cables, and there are naturally safety concerns about having dangerous voltages in close proximity to low voltage communications wiring. In other sections of the book, we've discussed the issue of separation from power cables. Many authorities have attempted to create guidelines on this issue. The recommendations from 2-inch separation in electrical codes all the way to a 3-foot guideline from building standards. This leaves a lot to the imagination. So what issues should be considered? The interference issue is fairly straightforward. Electrical power lines are not limited to carry only 50 or 60 hertz electrical energy. They can, in fact, inadvertently carry interfering signals at hundreds of megahertz. In one famous case, a 243 megahertz interference signal generated incredibly by a malfunctioning air conditioning relay was carried hundreds of feet along power lines from the offending source. Commercial and military aircraft use 243 megahertz as an emergency beacon and communications frequencies. Thus, This unusual power line interference was very serious. Eventually, the periodic nature of the interference caused the researcher to suspect that it might be an HVAC system that was the culprit. Now, we routinely use LAN equipment that generates and is susceptible to interference to or from power lines. The closer we allow wires to be and the longer we allow them to run in proximity, the greater potential that we have for interference. Thus, the basic guideline here is to limit both the run length and the separation of these types of cables into a divided power communications cable tray. It is very easy to run the two types of cables beside each other for hundreds of feet. This increases the chance for interference to couple between the cables, even if the separation is moderate. A good rule of thumb is to place power and communication cables in separate runs to avoid long parallel runs. The cable can generally cross at right angles or briefly run together with little or no coupling. Fortunately, the tight twisting and controlled geometry of modern LAN wiring minimizes the coupling to and from outside conductors. The safety issue is a little more ominous. Electrical codes, such as the NEC, forbid placing power conductors and communication cables in the same raceway. Power conductors are considered Class 1 circuits and are expected to have hazardous voltages and the ability to deliver dangerous levels of current. Communication cables, on the other hand, are Class 2 circuits as defined by the NEC, Article 800 communication circuits. The NEC also specifies a 2-inch separation from electrical light, power, and other Class 1 circuits, except when they are in a raceway or metallic sheath, or where they are separated permanently. For example, a LAN cable and a power conductor can be contained in the same power pole or modular furniture pathway if they are run in totally separate raceway sections. The main idea is to get from this discussion of power and data separation is that you need to keep power and data cables widely separated, except in that last run through the modular furniture fixtures, where the cables must be placed in separate raceways. Modular furniture presents challenges for LAN wiring, but it is an office technology that is here to stay. As more manufacturers respond to the special needs of data and communications cabling, the process of running the needed cabling in this type of furniture will become routine. Now that concludes this chapter. Move on to your online assessments and join us back here for Chapter 11. See you.